Hello everyone. Thank you for coming today. We will now start because it's 6:15. So thank you to everyone who's here physically, but also online because we have more people online than physically from all campuses. And I just wanted to mention that the people online, you can ask questions. We will be monitoring them, and we will be able to ask them when the Q&A starts. So without further ado, I'd let Miss Langlois, who is Sustainability Manager at ESCP, introduce this conference. Thank you.
Thank you. Thank you, Arthur. So hello, everyone, and dear Professor of the Academy, dear Professor Claude Jopard, dear Professor Geli, dear Professor Not. Dear students of the ESCP International Politics Society, and all of you joining us either online or in presence, we're very happy to welcome you to this new edition of this conference series, Major Challenges for the Future, in partnership with the Académie des Sciences. I'm Laetitia Langlois, Sustainability Manager at ESCP. And this session is all about ocean as the new frontier. And in another life, I used to work in the ocean protection, so this is very exciting for me. But actually, not only for me, also for ESCP as a whole. Indeed, we sort of have a history with the ocean. Not many people know that, actually, but if you visited us in our République campus, you might have noticed some anchors all around the walls. And, you know, you could ask yourself, why here in the heart of Paris when we are so far away from the ocean? Well, these were installed at the time where the school was home to the Department of Maritime Navigation. So this was a school within our school, and it was founded in 1905 and was meant to train long-haul captains. And while we no longer teach maritime trade specifically, we still believe in encouraging interdisciplinary studies, which explains why the work with the Academy of Science resonates so strongly with us and why we are very proud to collaborate. While we believe science is a public good that should be shared as widely as possible, it is also a key to educate our future global citizens' critical thinking. With that in mind, and you know, when we started our sustainability transformation in 1992, it became a cornerstone of our strategy to embed scientific knowledge within our teaching and beyond. Building on strong institutional references such as the IPCC, the IPBS, our courses have been devised to integrate this idea of interdisciplinary from the beginning. And with the goal of training 100% of our students, this is no small feat. As of late, there's been a new wind blowing for sustainability at the school with the launch of the Sustainability Institute recently, which has just signed a very ambitious partnership with AXA Climate to focus on the key issue of adaptation to climate change, with the creation of a new dedicated research center called RESET, and with the publication of our first ever federal carbon footprint, and soon our reduction strategy, which will be led with Professor Georgi Kerelev, who is the Associate Dean for Sustainability. When talking about climate change, it's impossible not to mention the ocean, as it is a key climate regulator. And this conference is particularly timely, as we are now halfway through the United Nations Ocean Decade. And we're leading up to the UNOC, which is the United Nations Ocean Conference, which will happen in Nice this year. I'm sure you will have many opportunities to talk about this during the talk. But this major event will actually address several pressing issues, including the Treaty on Areas Beyond National Jurisdiction, marine protected areas, illegal, unreported, and unregulated fishing, and much more. And it is essential that the ocean doesn't slip from our minds when talking about the future of the planet, because 1 out of 2 breaths that you are taking today is thanks to the ocean, as it produces 50% of the oxygen we breathe. So in the name of ESCP, I would like to thank the professors of the Academy, students from the International Politics Society, and all of you for being here. And I'm looking very much forward to the discussions. Thank you.
Good evening to all. It's a great honor for ESCP International Politics Society to moderate this evening's conference, Oceans, the New Frontier. It is with great pleasure that we host Dr. Louis Geli and Dr. Fabrice Not, who will provide us with invaluable insights into the dynamics of seafloor environments. Dr. Louis Geli, geophysicist and senior scientist, is the current head of the Marine Geosciences Research Unit at IFREMER. He began his academic journey focusing on geophysics, which led him to dedicate his career to exploring the complexities of Earth's marine landscape. His research has provided critical insights into submarine geological hazards, including seismic activities leading to tsunamis. Dr. Geli's extensive fieldwork on ships such as the Pourquoi Pas in 2014 and numerous publications greatly contributed to enhance our general understanding of seafloor dynamics. Joining him is Dr. Fabrice Not, senior research scientist at CNRS, stationed at the biological station of Roscoff. He completed his PhD in oceanography and marine biology at the Sorbonne University and specializes in plankton ecology and evolution, employing molecular and microscopic techniques to investigate these microscopic specimens, often forgotten, though indispensable. His research notably focuses on photosymbiosis, the symbiotic relationships between plankton and photosynthetic partners, and how these interactions influence marine ecosystems. Dr. Nott's work has been instrumental in uncovering diversity and ecological roles of planktonic symbiosis, shedding lights on their adaptive strategies in response to the environmental changes. This evening, Dr. Geli and Dr. Not will dive into the great unknown and walk us through the dynamics of oceans, this often forgotten part of Earth, when talking about the impacts of climate change. I would now like you all to join me in welcoming Dr. Geli on stage, who will begin his presentation, followed by Dr. Not.
Good evening to all. Thank you for coming. Thank you to Claude Jopard for inviting us here. Thank you very much for your invitation, Laetitia. We are very pleased to be here. Okay, so today we are talking about the ocean. The title is Oceans, the New Frontier. In fact, this is a very short title, The New Frontiers, because the ocean, what is the ocean actually is, there is an ocean of changes and challenges. So there are many things to talk about when we mention the ocean as the new frontiers. You see here in this slide the different topics that we could have been presenting here: CO2, temperature rise, sea level rise, acidification, pollution, invasive species, declining in fish activity. Well, there are lots of different topics, but we have chosen today to talk, to focus on deep ocean mineral resources. This will be my part. And then Fabrice Not will talk about marine biological resources. So for, yes. The ocean covers 70.8% of the planet, or the surface of the planet Earth. So it's huge, big, and deep. And in fact, the area below the continental shelf, below 200 meters, which is a photic zone where the light doesn't come there, is still completely unknown, actually. 500 years after Magellan, the deep dark ocean is unknown and unexplored. So things have accelerated in terms of knowledge since World War II. I will start my my talk with a historical retrospective of the major revolution in ocean research, starting with plate tectonics from 1945 to 1970. Of course, I don't talk about the pioneers from Alfred Wegener in 1912, but I will start here my retrospective with World War II, because an important thing is that ocean exploration depends completely on technological efforts, and particularly regarding plate tectonics, everything came from intense exploration of the deep of the high seas, I would say, during First World II, and the main scientists providing the plate tectonics model were officers in the U.S. Navy, and so after in the 70s we knew that the ocean was made of plates that are oceanic plates. We were given birth at mid-ocean ridges, and we were in the deep in subduction zones, and so the ocean was made of also abyssal plains and also volcanic intraplate features, like here, for instance. And with this exploration, we knew already before the end of the 70s, we already knew that there were mineral resources at the time. I remember when I started my career 40 years ago, we knew that there was, for instance, polymetallic nodules or polymetallic sulfides or cobalt-rich crust. Okay, so we knew that already. And since then, at that time when I started, it was already considered as the new El Dorado 40 years ago. And but we are still about at the same point. And I will try to explain why this is that so. And second revolution is the satellite revolution. Here again, the satellite revolution came because, well, it started with the Sputnik in '57, but after with all the space exploration. But fundamentally, all the progress that we made in ocean observation was due to the Star Wars that Ronald Reagan launched in the early 80s. And also, this is important to remind that like the deep exploration during after the Second World War, all these progress were made in conjunction with the technology that came from military development. But we gained a lot of knowledge with the Earth and ocean observing systems that flourished at that time. You see here the map of the ocean here above, and a map of, for instance, sea surface temperature. Okay, so the third revolution is the recent one, is the most recent one, which is the global revolution. And at that time, and this is also a very important concept to keep, very important concept, is that there is only one planet, and there is only one humanity, and we are all in the same planet, and there are interactions between atmosphere, between the atmosphere and the biosphere, for instance, between the ocean, atmosphere, biosphere, and also between the deep mantle and the ocean. But I will leave Fabrice talk about that. For us, what I would like to point out is a fantastic, I am fascinated by this curve, which is here the Killings curve, which was published, the first publications were in the early 60s. And since then, there were progress in this curve here that you see. it concerns the atmosphere. And what you see here, the experiment started in 1957 by measuring the concentration of CO2 in the atmosphere. And what you see in this curve, so you see here the increase of CO2 since the measure started. But what is very important and very interesting to note, I know here the assistance is not necessarily on scientists, but I think it's important things to quote, is that here you see these red curves. You have a mean curve here and red curves here. And these red curves, this is not noise superposed on the global increase of CO2. This is simply the seasonal effects of vegetation. For instance, you have a maximum of CO2 at the end of the winter when you had no vegetation, and at the end of the spring you have a low because the atmosphere has the vegetation has absorbed CO2. So I talk about, this is not the main topic of my talk, but this is fascinating curve, which means that since the first presentation to the President of the United States was in '67 by President Lyndon Johnson, and the interpretation was there in '67. Okay, so next. No, I'm very bad in moving these slides. Okay, now what will be the next revolution? Okay, now, and you see that ocean research has always been driven by transition, big scale transition. And today, everybody talks about green energy. And green energy, when you talk about green energy, then that means you need mineral resources to fuel the green energy. And for instance, here in my slide that I don't see very well, but you need a lot of mineral resources that can be used in your cell phones, for instance, but also in your solar panels or in your electric car. You need batteries, and you need very rare elements, for instance, particularly in windmills, for instance. So the idea is that the green energy revolution will be fueled with energy, with mineral resources. And so the question is here, we know there are mineral resources in the ocean, so is there a future for mineral resources within this context of green energy? So the mineral resources in the ocean, we knew that as I said, since the very late 70s, early 80s. There are different types of interesting mineral resources that are, as you see here, for instance, you have hydrothermal deposits that are associated with mid-ocean ridges, and you have massive sulfide deposits there, which provide copper, zinc, gold, plate, a number of mineral resources. You have also the nodules, water, deep sea nodules, which are in abyssal plains, for instance, in the Pacific, and these nodules are made of concretion, sedimentary concretion. So they form very slowly due to the concentration of geochemistry elements in the deep sea floor. And finally, you have cobalt-rich crust, which you can find in what is called hotspot environments, for instance, in Tahiti, in this interplate volcanism associated with interplate volcanism. So you have cobalt, platinum, and a number of resources that can be used, for instance, in electric vehicles. So, regarding nodule, for instance, just would like to tell you a story. Is that when I came to Ifremer, which I'm working there for 30 years now, there was a friend of the family who created the society COMEX. COMEX was a society established in Marseille for deep divers working in oil and gas industry. And he told me, "Oh, you're going there to Ifremer working on nodules. I tell you something. When these nodules will be interesting, you will have white hair." And here I am. Let's see why he was right. So okay, so all these mineral resources. Well, most, not all, but most of these mineral resources we are talking about are in fact far away from the coastline, and they are in outside the zones of under maritime national jurisdiction. So let us here remind what are the present-day maritime jurisdiction. So the ocean is, you have here the coast. You have 12 miles, which are in fact that belong to the country, territorial waters. For instance, the police can go there and intervene in these territorial waters. You have the economic exclusive zone, which is 200 miles from the 12 miles. So you go to 200 miles, and all the mineral resources of below the seafloor belong to the country, and also the fishing, and you have the country has exclusive rights on fisheries. Then you have another part of the area, which is of the delimitation, which is the extension of the continental slope here. So this is called the continental slope here, and you have the extension of the continental slope, which can go to a maximum of 350 miles from the coastline. And here you still have, if you have done what is required to be done to the UN nations, if you have established your rights there, so you have an exclusive right of the mineral resources there. And after that, you have the high seas. You have the high seas, so everything is the high seas. All countries may go and fish there and catch what they want there. But after this line, in the high sea, there is an area which the area is depends. It's called the zone, international zone. We call that the zone. When you hear that, the zone means the area which is beyond any national jurisdiction. And there, so this is the way it is. And most deep sea mineral resources that have been talking here are located in the zone. Not all. So let us talk now about this question of how it was. So a little bit of history about how this maritime right was built. So everything is based on Truman Declaration in 1945, which is a starting point, and this is a reflex that is common today also, which always is like a normal reaction, is that everything which is on the continental shelf needs to be exploited for human. Okay, and here, and then Truman declared the continental shelf around the United States as the exclusive property of the United States. So what is in mind here is really you have an apple. The apple is made for man to be eaten by man. Okay, so and you have, and this is the founding process. In 1957, you have the Antarctic Treaty. I call that because you will see that there are relations between the laws of deep sea laws and also the Antarctic Treaty and also the climatic treaties. So the Antarctic Treaty in 57 was in order to prevent nuclear explosion in the Antarctica, and then it's very simple. All military activities in Antarctica are forbidden. Dot. You don't talk. Very simple treaty. And after many years, so in 1982 there was the UNCLOS, United Nations Convention for the Law of the Sea, which was established in 1982. But there was a problem with this convention in 1982, is that the question of mineral resources was set apart. It was supposed to be related to part 11 of the convention, but it was it was not adopted by main industrial countries, and namely United States, Great Britain. At the end, the other industrial country accepted that, but between 92 and 1982, sorry, and 1994, which was the time where this part was eventually accepted, there were lots of discussion in order to know how to do, because the problem, I see, well, there is something that I didn't mention here, is that in 79, 81, there was the revolution, the Reagan-Thatcher revolution, which changed totally that was a change in economic system, and that was called the neoliberal revolution, and the discussion, now to come back to the sea, is that between 82 and 94, the discussion was to make consistent two principles that were looking contradictory, which were the area is the property, is the common heritage of mankind, and that's the first point, and the exploitation of mineral resources must respond to free market priorities. And then since then, so in 1991, the part one was adopted, accepted by the United States and a number of other countries, like Turkey, for instance, but for other reasons. But the United States accepted first and then never ratified the treaty. And so after that, but I pass because I need to go faster, you say. And since then, since 1994, there was no exploitation at all, because the discussions are still pending. This discussion is still pending, and in my opinion, I'm a scientist. I'm not supposed to have opinion. I have to stay on facts, but I have opinion. At my age, I have opinion. Sorry, and is that these principles are incompatible. They are incompatible at the point that since 1994, there were 30 exploration permits which were delivered by the International Seabed Authority, but still no mining code, and deep sea mining code, which is still expected. And then I go fast. And then a discussion started, and it started very sharply recently. It is, the arguments are always the same. There are pros and there are contras, and for deep sea mining and against deep sea mining code. And eventually, for different reasons that you can read here in this slide, but the result is that today, at the International Seabed Authority, there is a global tide of opposition to deep sea mining. That was said by Emmanuel Macron in 2023 in Lisbon. And there are now 32 countries which are mentioning that we should do a moratorium on, some say we should do a moratorium, others are against simply deep sea exploration, that's it. And the debate is still going. So my last slide is that, is really deep sea mining the next revolution? My personal answer is no. I'm sorry, I'm sorry, I should not have this give answer, but my conviction, my personal, I'm not talking of scientists, but my conviction of someone who has been hearing this story for 40 years, I think that the answer is no, definitely no. And if the word, in my opinion, now this is purely opinion, this is not science, I think that the world needs symbols. And one symbol is the Antarctic Treaty. I didn't say that in 1981, in the Antarctic Treaty, the biological resources are preserved, and there is also no exploitation of mineral resources in the Antarctic. Okay, so I'm finished. I'm been very long, but enough to give now way to Fabrice Not.
Okay, I'm a bit shorter, so I'll do it like that. Okay, so well, thank you very much and for the invitation, and thank you for being here. So in my talk, following back Louis, I'll try to give a more of a bio-eco oceanography perspective on oceans-related scientific topic and challenges. So when we're talking about oceans, what are we talking about? I mean, it has already been mentioned before by Louis and by Laetitia, but indeed what we're talking about most of our planet's surface. This is 71% of the surface that is covered by the oceans. And the oceans have an average depth of 4,000 meters, which is very deep, which is very complicated to study. And one thing which is important is that light that comes from the sun, and if you think about it at the global scale, the light from the sun is probably the most of the energy that comes to Earth, basically. And this light from the sun penetrates the ocean down to 200 meters at the maximum. Usually it's more like 100 meters, but these 200 meters, it's called the euphotic zone. That's where the light enters the oceans. And this is very important because there are a lot of things happening in that thin layer of the ocean, and I'll get back to that later. And then something which is very important as well is that nearly half of humanity lives on the coastline. And obviously, there is a strong relationship between human societies and the oceans, and then we will try to look at that. So just to give you a few examples, I mean, tourism. I mean, this tourism, it's really a substantial source of incomes for many countries, and it increases like every year, like about 6%. Shipping, like 90% of the by volume of the international trade is through shipping routes. And desalinizations, now, this is very important. As you can see here, there is actually 97% of the water on Earth is salty, right? So there's only 3%, and actually most of the fresh water is frozen, right? So desalinization is a very important challenge, and especially in Middle East, North Africa, and these countries. And there is a fisheries, aquaculture, fossil fuels, and all these topics are very important for human societies, as you can imagine. And so people used to talk about ecosystem services, and there have been estimates of these ecosystem services. How much does it is valued? This is a tremendous amount of money, as you can see here, and this is from 2014. But actually, my point is that oceans brings even more than that, more than this amount of money. And ocean brings something that is actually invaluable, because ocean brings the habitability of the planet in a way. So the equation is quite simple, in fact. There is no ocean, there is no life on Earth, basically. And just to illustrate that point, so for one thing, here you can see Earth's climate is regulated by the oceans, because the oceans are the currents of the oceans. They are actually distributing the heat that is stocked at the equator and distributes the heat at the higher latitudes. So it's basically the central heating of the planet is through the ocean's circulations, these thermohaline circulations. And it takes about 1,000 years for virtual particles to go all through this path. So that's one thing. But oceans actually regulates our environment through other ways, and in particular through something that we call the biogeochemical cycles. So that's what the scientists call the biogeochemical cycles, is basically the cycle of the basic elements in the planet. So like oxygen, for instance, or carbon, for instance. And if you think about it, let's take the carbon biogeochemical cycle. So if you think about the carbon biogeochemical cycles, it all starts with a very fundamental chemical reaction that is called photosynthesis. And this chemical reaction is made by life. It's actually performed by living organisms. And this is the photosynthesis reaction. So the photosynthesis takes carbon and water, uses the energy from the light through the pigments that capture these lights, these photons. And this energy is used to produce complex organic molecules and release oxygen. And this is a fundamental reaction, chemical reaction. And actually, it is important to note that this is a global photosynthesis, and half of these photosynthesis reactions is produced in the oceans. So if we look a bit more carefully about the carbon cycle, biogeochemical cycle in the ocean, so what you can observe here is that basically, as I just told you, that using the life in the ocean, there is the pumping of CO2 and the release of oxygen production. Laetitia mentioned that one out of the two breaths, half of the oxygen on Earth is produced by the ocean. And then through this, what we call primary production, because these small plants that live here, that do the photosynthesis, basically, this is the very base of the food webs, right? And then that leads up to the big fishes and everything that is used by humans and societies. But there is also something that is important in that carbon biogeochemical cycles, especially for the carbon sequestrations, is that through the photosynthesis, it is using CO2. And then when the CO2 enters this system, part of it goes through the food web, but a large part of it, whenever these organisms die, they actually sink through the ocean. And when they sink through the bottom, through the oceans, and right all the way down to the bottom, this carbon get buried in the bottom of the ocean, which is very important because when it stays there for hundreds of millions of years. And this is a major difference compared to terrestrial ecosystems, for instance. If you think about it, whenever carbon molecules, carbon atoms here enters into a tree, it's gonna go into a tree, then stay there for, let's say, a couple of hundred years, and then eventually it will be eaten by some other organisms or burnt, and then get back to the global system. Like the turnover of a carbon molecule in terrestrial ecosystem, it's a couple of hundred years. Here we're talking about geological time scales, right? And then the carbon that goes down to the ocean stay there for a long time, a very long time. And it's actually most of the fuel and gas that we are using now is actually coming from this marine life over geological time frame. So this is very, very important. And you see that the ocean is way more than these resources and ecosystem services, basically. So you say, okay, so we've seen previously that this living part here is very important, but thinking about it, okay, so what's actually the life in the ocean composed of? So this slide is very important. This is as important as the photosynthetic reaction, basically. And I'm going to walk through this slide. So when you Google, that's what I did actually, ocean biodiversity, what you get is coral reef, whales, and that kind of organisms. But all these organisms actually belong to one branch in this tree of life. So what you're looking at here is the tree of eukaryotic life. So I'm not considering bacteria here, I'm just considering eukaryotes. And this is a tree of life. So the tree means the evolutionary relationships between lineages, right? So it's the genealogy of life, basically. And my point here is that on this diversity of life, one branch here corresponds to humans along with all animals you can think of. In that tiny branch of the diversity of life, you find humans, you find fungi as well. Meaning that, evolutionary speaking, a human is closer to a fungi than a human to a plant. This is land plants, right? But if you look at it, in every single branch of this tree, you will find some marine life, right? So my point is that these distant evolutionary relationships among the life is very important, way more important than a human and a fungi. Another point here that I want to stress is that most of these lineages forming this biodiversity are unicellular. They are basically microbes. I'm not saying bacteria, like eukaryotic microbes, right? And the only branches of life that have a multicellularity, so you basically that you can see with your naked eyes, are the one with humans and animals, the one with the red algae that you can find if you go in the sea, you can see these red algae. Here there is a green lineage, so the plants, land plants, right? All of them. And then there is here the brown algae. So those four lineages are the only one that are big, basically. All the others are unicellular. Very important to have in mind. And all of these lineage, you can find them in the ocean. Okay, I think this is very important to have in mind. And there is a lot of diversity between these lineages. Okay, so I told you that most of the ocean diversity is actually microscopic, and we used to call that plankton. So here you can see on this satellite image the amount of chlorophyll at the surface of the ocean. And you see here the green are the chlorophyll. So these are the phytoplankton. It corresponds to the oceanic forest in a way. So you're looking here at the oceanic forest. And you can see these tiny organisms from space through the satellite, through their chlorophyll. And actually, all these plankton, there are a lot of diversity, and depending on their features, they can have different impact. So if you zoom in Here it's again a satellite image in the English Channel, so this is the south of England. And you can see here this white part area in the sea. And this white area in the sea is actually composed of this tiny ball here, which is a small phytoplankton. It's only 5 micrometer in size, but you can actually see it from space, right? And this is called Emiliania huxleyi. This is a very important. And you see this particular phytoplankton species has some kind of plates like that, and these plates are biomineralized. So these living organisms make plates. It produces plates made out of calcium carbonate, which is chalk, basically, right? And this is very important. So whenever this large bloom of this phytoplankton dies, it all sinks to the bottom of the ocean, and then it produces, like over geological time frame, it produces cliffs, for instance, or gas, or fuel, and that thing. And this is another example of phytoplankton, so different features. This dinoflagellate. So between this plankton and this plankton, there is a huge evolutionary distance, way larger than human and fungi again, right? So I'll just get back to that one. So the coccolithophores that I'm talking about are here, and the dinoflagellates, the other ones, are somewhere here. So you see the time, the evolution time frame is completely different. And this species produces toxins, and this is very important. This is very important because it also has some economical impact on human societies, but also some social impact on societies. So see, these tiny organisms have a very important contribution to the oceans. Obviously, when you think about it, like in a drop of seawater, you find organisms that are very different, evolutionary speaking, and this fragile equilibrium is under stress. And I'm not going to go through that. I mean, there are plenty of documentations, but all the indicators point toward the same direction, right? So I just want you to see, for instance, the marine heat waves. I mean, it will change the timing of the blooms, so it will, eventually it will change the whole ecosystem, basically, because, you know, all these seasonal successions. Ocean acidification, let's take that one, you know, because it's more acidic, then it will dissolve all the calcium carbonate, you know, the chalk is dissolved by the acid. So basically, ocean acidification will have a strong impact on organisms like that. So here we go. So basically, on this here on this plot, where you have the likelihood and the impact, the strength of the impact, you can see that all the environmental issues and risks are actually very high likelihood and very high impact. So that's something we might consider. So, and in such a rapidly changing environment, one of the challenge, in my opinion, is to be able to observe the ocean. So ocean observation is something that is fundamental and critical, in my opinion. There are like, we do have sensors like to measure temperature, to measure salinity, to measure some nutrients in the environment. And this is very important to do it at a broad spatial scale, but also a very, what I think is very important is the temporal scale, because we've seen that the changes are occurring very rapidly, and these processes, these biological processes in the ocean have geological time frame significance as well. So, I mean, the spatial and temporal times observation are very important. And we do have, as I was saying, we do have very nice sensors for physical, chemical parameters, but something which is more difficult to observe and is the biodiversity and the biology. It's a nightmare to observe. And I think, I mean, Louis was mentioning some revolutions. I think one revolution in biological observation of the ocean is the genomic revolution. So now we are using DNA in the environment to evaluate the biodiversity. And I think this is a major change. So this is represented here. You can see on this plot here the cost of sequencing DNA, which is dropping drastically. So here, this is 2010. So it starts 2001 and 2017. See, and so the cost of sequencing make this genomic revolution possible. And here is the number of marine sequences of DNA that have been patented, right? And then again, it's the same time frame from 2001, 2017. And so you see how much the DNA is changing the game here. And something that I want also to stress here is that's a study, a global study of the genes in the ocean. So each bar here, each column, it's oceanic regions. So South Atlantic, for instance, Southern Ocean, South Pacific. So you see, and here different depth. So this is a surface, and this is mesopelagic, so it's 600 meters. And you see that the deeper you go, the more the genes are unknown, which is the novel genes in red and the known one in blue. So indeed, the deep ocean is really a next challenge because we don't know much about the genes that are actually down there. So that's a critical point as well. So ocean observation. So it's good that we observe oceans like hard science, let's say, like physics, chemistry, biology now. But there is a concept that emerged recently that is this concept of augmented observatories. And then along with this biology, ecology, which are actually new with these new approaches of environmental DNA, we are trying to also include social science and stakeholders. So we do the observation in a meaningful way, right? And this is an example of a project that a colleague and myself actually are coordinating. It's a national project. It's called Future Ops. And it's basically gathering all the main French institutions dealing with oceanic sciences, where we are trying to set up a new way of observing oceans. And just an example here on the social science part, this is a collaboration as a partner with a media lab in Sciences Po, where people are using their numerical traces in social networks to understand the usage of the coastal ecosystems. And then we are trying to link this with more like classical parameters, let's say. And I think this is a big challenge. One of these big challenges is to integrate the big data that are generated, the big data that are generated by genomic sequences with also heterogeneous data coming from social science, hardcore science, and this. This is one of the main challenge for the future, I guess. Okay. So all these ocean-related topics actually are currently benefiting from, I think, a pretty positive context. And it has been mentioned before, we are in the middle of the UN Ocean Decade. That is a lot of effort on ocean sciences. And then France and Costa Rica, actually, but this is going to happen in France, are organizing the next UN Ocean Conference in next June. So if you are interested in the topic, I recommend you to follow that. And one governance that should be launched during this conference is the IPOS, is the International Panel for Ocean Sustainability. So a little bit like IPBS for biodiversity or IPCC for the climate. And France has been really leading this effort. So there is the creation of these international organizations to make the link between the science and the policy. So yeah, if you're interested, just stay tuned on that. Okay, so I think so just to wrap up, I just want you to get back on a few very important messages. Is that okay? Ocean is not only providing resources and services. It's also essential for life on the planet. So we might be better taking care of the oceans. And Earth is a closed system, right? So if we use up all the resources, there is no more. And it takes time, right? We are talking about geological time. Another point that I'd like you to remember is that all these global scale processes, these geochemical processes, are actually regulated at the microscopic scales. And most of the biodiversity is actually microscopic. And the third point I think is important is that if we want to have some kind of meaningful observation of the system, it has to be holistic. We need to consider all together to make sense out of the observation of the ocean, and this is especially more important in the changing times. Okay, so obviously I just scratched the surface. I didn't go into the details, so I just here bring a couple of resources if you want to go further. The World Ocean Assessment, so the 1, 2 was in 2021. The third is in preparation, so that's something you can get a lot of information from. And there is this Plankton Manifesto that has been released last year. So very interesting. And then if you want to think about, oceans and climate change, I suggest you to have a look at these two recent books that are very interesting. And then maybe just for the French-speaking community, and I'm sorry, there are a few resources that you can check. There is this Planktomania project. There is a YouTube channel. There is also English actually versions. So there are some videos for that. And this one is actually has been out this month. And then there is these two books that are Tout comprendre ou presque sur le climat, on biodiversity, climate, and just for you to stay tuned because there is one that coming up soon this year on the ocean, dedicated on the ocean. Thank you for your attention.
Thank you for the two presentations. They were very, very insightful. So we will ask a few questions and then we will leave the floor to the room and to the people who are online. So again, if you're online, you can ask your questions. We will be getting them. And perhaps to start with, before the conference, we briefly talked about the concept of digital twins. And I was wondering if you could explain to the audience what we mean by digital twins for the ocean. How far are we now from getting one, and what could we get from it?
Yeah, I guess that question is for me because we were talking about that and you were not here. So, indeed, yes. That's one. There are actually large European projects, and I'm sure it's the same in other countries, like or part of the world. One challenge is to build this digital twin of the oceans. So it's basically modeling the oceans. But all the parts of the oceans. It's not only modeling the currents, it's not only modeling the diversity, it's like putting all this heterogeneous kind of data together and trying to model a digital ocean, basically. And that would be very useful to change some parameters and to see how. But we are far from there. I mean, this is even though there are a lot of people working on it, and it's really interdisciplinary, of course, and it's really challenging. So, but this is the aim. This is the goal. So yeah, a lot of work.
And is there any international cooperation behind that, or?
At the European level, yes, to my knowledge, at least. I'm not aware of any collaboration besides individual research project, I mean, I'm not aware of international beyond Europe collaboration.
I think I had a question for you, Mr. Geli, about when you were talking about the fact that you think there wouldn't be any mineral revolution like mining the deep sea. Made me think about the quite high environmental impact that mines on land, I mean mineral mines on land have. Do you think maybe this high impact, which is actually a bit more, appears more in the media, could lead countries to actually, well, develop deep sea mining, or what would be your take on the subject?
Yes, something maybe I didn't mention practically was that the deep sea environment is really severe. I mean, as long as it's not for men. You know, deep sea, the deepest part of the ocean is called the Hadal part, Hadal, from Hades, the Greek divinity, which means that this is for the dead, Hades. So the conditions in the deep ocean are very, very, very complicated due to pressure, mainly due to pressure. And so you need very large investments to reach the deep sea. For instance, at the moment, there are only 5 countries in the world that have deep sea submergence down to deeper than 4,000 meters. These are the United States, Russia, France, Japan, and China at the moment. You have some few billionaires who have got some means of exploration. For instance, James Cameron in the Mariana Trench, which means that it's a very, very strong environment. Well, very large investments. So to date, and this is probably the main reason why there is not yet any deep sea mining code, is that actually the investing there is not for tomorrow. Okay, so but you never know about science. We are scientists here, and so you never know what the future will be made of. So I cannot tell. But today, based on what I know, I think it's very difficult to reach. There is something I didn't mention. Also, I didn't talk about what is going on in exclusive economic zones, which is 200 meters from the coastline. And for instance, in Norway, the Norwegian, they have a very large coast, and they have a lot of experience on deep sea exploration based on oil and gas. You know that Norway is one of them, is a very strong country for deep sea, for oil and gas. And so they have developing methods for exploring outside the zone, because that is in their seas. So maybe there will be progress, but you cannot escape to physical laws. This is like living on Mars. You know, there are physical laws, and I do not see how you could colonize Mars. It's a bit like, but this is what I think now. I will be dead when there will be some exploration. Or for exploitation on the deep sea.
And perhaps related to that, you both work on oceans, but you work in very different disciplines. What is the percentage of unknown in your discipline? Like, do you have an idea, or like how much do we don't know about the oceans?
This is a very interesting question, because there are much more things that we do not know than things we know. Definitely. This is the way science works. This is the beauty of science.
Yeah, maybe just to give you orders of magnitude, on topic that I'm familiar with, like in genetics, for instance. Whenever you take a sample from the ocean and you look at the genes content, there is pretty much like 70% of the genes that you don't know what they are. So that's something. And talking about biodiversity, as I try to explain in the talk, most of the diversity is unicellular, is small, and then when we look at the diversity in the oceans, we do find, even nowadays, new lineages. I mean, I'm not talking about a new species or, no, a full new lineages of life that has been on Earth since hundreds of million years, and then we didn't know that was there. And so, yeah, we are still discovering new life, new forms of life in a way. And on this life in the ocean, the genes that are in the oceans, there is right now 70% we don't know what they are. Yeah, so that gives you a big figures.
Thank you. And maybe one last question before we give the floor to the room. Do you have any personal expectations with the UN conference on oceans in Nice? What do you expect as a result? Is it only, well, mainly advertisement about the oceans, or is there anything concrete that you expect from different countries?
So I will repeat something that I said during the interview that Mr. Day made just a while ago. In fact, your students in management school, business school, and what I answered to the interview was that a very important point is that we really need to have international laws and conventions. And when you will be a manager, it's no way to dismiss or to disregard regulation. There is a big story today about regulation. We have too much regulation, which may be true actually, definitely. But these regulations and the coordinations between multilateral institutions and countries is really worthwhile because it's based on scientific observations and so on. So in terms of manager, the most important thing is to take it seriously. Seriously. 20, 30 years ago, well, times have been changed, but there was a real disregard of these regulations. But time is now coming back that people are arguing for less regulation. Of course, we have to balance the regulations and so on, make them realistic, but it's important to know that these, for instance, the outline and what will come out of these symposia in Nice, for instance, is not for fun, is to be taken seriously.
Yeah, maybe I fully agree, and indeed, I mean, as we've explained, I mean, most of the oceans are beyond national jurisdiction, so we need, I mean, we as a humanity, we need some kind of coordination in the governance of this part of the earth, basically. So that's what we can expect. And just to mention that before the UN conference, which is very much political, there will be a scientific conference, and there is also going to be some ocean literacy events around this, which I think is very important. So I mean, the whole thing in Nice lasts for a bit more than 10 days, even though this national conference, I mean, political conference is only 2 days.
Okay, thank you. So we have questions online, apparently.
Yeah, actually. So the first question, what do you think about oceans, food safety and water quality?
I can try to answer. Well, what I am thinking about it, no, I think food safety is obviously something that is important, but then we are in this exploitation relationship with the oceans, and that needs to be monitored, and water quality and aquaculture. I know there has been in the news a few days ago, actually. I think it was in Norway, some large aquaculture facilities that of salmons that have escaped in the wild, and there were some headlines like in the newspaper, because I mean, escape of these fish farms that have some very controlled genetic backgrounds and everything that would merge with the wild populations, and that would be actually a threat to the wild populations. And so, you know, these issues are very important, because by releasing some farmed fish, you can put in danger the wild population. So that's the kind of stuff. So yeah, and water quality, there's issues with the pollutants, chemicals, and yeah, obviously, and plastic pollution. So.
I'd like to give a compliment to your last question, which is not unrelated to what Fabrice mentioned, is that what has changed with oceanography and marine biology, atmosphere studies is think globally. And the question is that the atmosphere is the property of mankind, and ocean also. So pollution, for instance, this is a big deal today regarding pollution, is that what the fish eat, well, you get that back into your plate. So even if fish eat in the Indian Ocean, you get it back in your plate here. So very important, and we have to preserve that through international conference and so on, to preserve that. We need to think globally. There's only one Earth. There is no planet B, as Laetitia said. And all this is important. For instance, regarding fisheries, when you have cream to be nice with the sun and to be nice looking person, so these creams, they are assimilated by fish, and they produce also biological reaction in fish. This is a very interesting thing. Well, and all this is like that. Mm-hmm.
Yeah, so we have a second question from a different person. So David asked about the UN Ocean Conference in June will be a key political moment. What would you wish as tangible and positive outcomes?
Yeah, maybe. So it's been a little bit like the previous question, and I think this that I was mentioning, this IPOS, would be a very great outcome if a lot of countries get involved in that organization. So that would be one great outcome. And I think there is I know there is a list of recommendations that is being prepared. That will be signed by the different countries. So I hope this list of recommendations will be ratified by as most countries as possible. So these are kind of outcomes we can expect, I guess. And that goes towards the coordination of the governance of seas.
Hi, I have a question. There's been a lot of disturbance in the deep sea. And recently we've seen several species that usually live in the deep sea go up towards the surface. And most recently, actually, on social media, there was a little bit of a buzz around the anglerfish. You've probably seen it. What is your thought on that? Do you think is this linked to human activity? Is it climate change? What pushes this species, or is it just a normal thing that happens?
I cannot answer.
Well, I can try. No, there's one thing in the lab. I work in Roscoff, and I know there is a national. I'm talking about the French community. I know there is a national project on trying to evaluate indeed this deep sea mining or deep sea exploitation on the life. So the people I know are actually looking at hydrothermal vents. You know, this oasis of life because of the fluid from the earth. And they are trying to look at the genetic connectivity, because these oases are distant. So whether there is some genetic connectivity between these, and yes, there are actually. So if you my point is that if you destroy part of the seabed because you are exploiting it, you are disturbing the whole ecosystem, even for the biology that is living down there. And there is also some studies that whenever you are like scratching the bottom of the ocean, then you are resuspending a lot of minerals and stuff that actually are going to impact the upper water column. And then so you cannot, you're not going to go like handpick all these resources. So it's going to be something rather brutal, and it will have impact on the oceanic life around and above, actually.
We have a question there. I can pass.
My question is for Mr. Not. You were talking about marine life and about how when they die, they go down to the seabed. It's a bit superficial, but what happens to humans when they die, like when they drown? Do they also go to the seabed, or like how does that work?
Well, yes, probably. Like everything that dies at some point will go down. And there are actually, and we've been mentioning that a little bit, like large whales or things like that actually die. At some point they sink. And then this is creates at some point temporarily oasis for life on the seafloor. So large animals and everything that dies at some point sinks in the ocean. And then it's feeding life on the seafloor, and on geological time frame, actually is building some resources like oil and gas, and, but this is over a geological time frame. Yeah.
Do we have any other question in the room? Online?
Yeah, actually, we have one more from Eve. What do you see plastics or microplastics as a challenge as well?
Definitely yes. Yes, this is a main issue. Plastic pollution is a very large concern at the moment because it's a real impact. First, plastic pollution has a real impact on marine species, first, and second, you've heard maybe in the news that there is this continent of plastics. You have probably heard of that. And in fact, sea currents are eddies. And eddies, it's not on the surface. This is not currents on the surface, but these are currents that account for a deep water column. I mean, it's not plastic that is floating at the surface, but actually it's plastic that is down deep. I mean, you have modeling by a physical oceanographer that show that you have in fact not only a continent, but it goes down, which is tremendous because it's not a few centimeters of water that is concerned, but you go down deep. No, plastic is a major problem. And when you go, wherever you go, you find plastics. That's tremendous. And now there is a consciousness about plastics. It's a challenge. We could have made a presentation on the next challenge for deep ocean, for the ocean, which is plastic pollution.
Yeah, maybe I can add something on that. Is that I think that, well, obviously there is the plastic you can see, and there is the plastic that you cannot see because it has been broken down in tiny pieces. And because I'm going at sea regularly and I'm collecting plankton with we use plankton nets. It's basically like nets you tow in the water and then you concentrate what's in the water. And then whenever I do a plankton net, then I see plastic particles. So because so that's something you wouldn't see by the naked eye, but actually, and these tiny pieces of plastics, you sometimes you can see some like we call zooplankton, which is rather large plankton with ingested particles of plastics inside actually. So and then that goes all the way on the food web, right? You understand that. So I mean, this is a major issue because I mean of these continents of the plastic you can see, but also because all of the plastic you do not see, and that is actually being all over the place, in fact.
On the topic of pollution and plastic and stuff like that, the work that the Ocean Startup is doing, I don't know if you've heard of it, but it's a company that like they've created a device that like kind of helps with pollution and clearing the ocean. My question does kind of rely on if you've heard of it.
No, not specifically this association or this organization, but there are many organizations that are trying to clean the ocean, let's say, from plastic pollution in particular. But I think the problem is not cleaning it, the ocean is like not polluting it, you know. And I think I mean, if we want to solve the problem, is we have to consider like before the plastic arrives in the sea and it goes through the river, and so there is a whole thing. So I think this is very nice work that these organizations do. I mean, it's very important, but it's not enough. That's my point.
Thank you very much for your very thought-provoking presentations. Do you know if the forthcoming conference in Nice of the United Nations will also address the ongoing negotiations within the World Trade Organization regarding a treaty on plastic pollution?
No, sorry, I don't know. But I mean, I could check after the conference, or you can go on the website and maybe check if whether this is one of the items. But out of my mind, I couldn't tell. No.
I don't know either. But I would like to do some parallel between plastic pollution in the ocean, like Fabrice said, which is microplastic. The main issue is microplastic that you do not see, but you find it in fishes and so on. The parallel is with the CO2 in the atmosphere. CO2 in the atmosphere, you don't see it. If CO2 were green, you'd see a green sky, and nobody would argue about is there that much CO2 and so on. Plastics you do not see, and while in rivers, on continents, you see it. So in politics, it's easy to take measures to reduce plastic pollution on the continent. For instance, like when Jacques Chirac, our president, when he was the mayor of Paris, he promised to have a swimmable river Seine, because you had plastic there and everybody could see it. Well, it took 30 years before we could really prepare the Olympics in the River Seine in 2024, because the problem of plastics in the continent, you see it. And that's the way. And this is why science is very important. The science improves the resolution, improves the methods for measuring, and this is the work of science, is to let you see what you don't see with your eyes. I think this is probably the main role of scientists. This is why it's very I'm very disappointed by politicians that disregard science. Science is to bring you your glasses on what you wouldn't see if you had with your own eyes. You see?
Yeah, actually, we have one last interesting question online. So, if you would have 1 minute with top CEOs of large companies, what would you say to make them aware about how ocean challenges may affect their business?
Well, well, in terms of first, in terms of research, now we understand. Well, nobody contradicts the fact that CO2 emissions produces the climate change that we observe. But in terms of research, we still have to work on, for instance, at the question of attribution. So, such event, is it? Can we attribute this event to, or extreme event to climate change or to CO2 or to human cause? So, in terms of science, there are still things to work on. My first thing is to encourage science, not discourage science. Encourage science. I repeat that 3 times, because you keep aware of things that you don't see. This is the same point, the last one. And the second point is you have 2 scale of visions, short term and long term, and the benefit, the long term benefit, is way more important than the short term benefit, actually. And this is what I would say. So measures to prepare the long term are the good computation. Well,
yeah, that's actually what I would say as well. I mean, I would say, you know, if you want your business to be profitable in 50 years from now, then pay attention to what makes your business running, actually, and to the oceans.
All right. Maybe one last question on technologies. With many emerging and not so emerging technologies, which ones do you feel will be the most useful in your job, in research on oceans? It could be AI, as Ms. Langlois told at the beginning. It could be quantum. Like, do you have any technologies in mind that will really impact your field of research?
Well, I can start if you want. Yeah. I mean, I have 3 things in mind, actually. Because that's my my research. So you're asking for my research is like, and in the observation of the biology of the ocean, I think right now to get the genetic sequence from the ocean, you still need to go collect, get back to the lab, do the sequencing, and analyze your data. And I think but I think we're not so far from it. It's like doing the sequencing in the environment, and then if we manage to do the sequencing on the environment and to analyze and process the data on site, I mean, this is going to be a game changer, I think. And I think what will help to do that is the AI, indeed, and this, hopefully, the quantum informatics, maybe. I mean, I don't know. We are not there yet, but you know, thinking about like years ahead, maybe.
Regarding climate, for instance, in the ocean, when you look at the killing curve that I showed, where you see that these kind of seasonal changes in CO2 content in the atmosphere, the seasonal change means the effect of photosynthesis. So for me, but I don't know if I'm authorized to say that, probably the most profitable issue is to plant trees. Definitely. I personally, this is also my personal opinion. I'm talking about not a scientist, but I do not really believe. I am very skeptical about the green technology revolution. Very skeptical, because in my opinion, what we need is more to be modest. To be modest. What I would recommend is modesty, is humility. Humility, this is probably the key. But is man made for humility? I don't. So I'm for green technology. Well, also a recommendation for you. as young managers, future managers, is beware of greenwashing. Beware of greenwashing. And you in your school, it's particularly important. Beware of greenwashing. When you know some subject, you're completely scared about what is said about we are finding the solution and so on. And to be optimistic, one solution: plant trees. I don't see any other solution at the moment.
No, I had a comment on a question that I could have been asked, but I'm not going to ask my question myself. But it was about, I'm not so so it was about geoengineering. I mean, I think that's a big issue, and I think we shouldn't, and as Louis said, we should be humble and not play too much with the with the ecosystem, because geoengineering can be very dangerous actually. So just,
for instance, carbon capture. Carbon capture and storage in oil fields and so on. Well, if the producers of carbon pay, maybe okay, but because they know much more than scientists of what is needed to do to drill and to inject carbon dioxide back to the earth. But this is typical something that I do not believe, because this is not religion. I really do not think that there is a future in that. Yeah, but.
All right, thank you. Well, do we have any other question? Cool, then we can wrap up, I guess. So thanks a lot to the Academy of Sciences, thanks to ESCP, and thanks to our two guests. I think it was very interesting, and it brings a topic that we don't necessarily talk about every day, at least in a business school. So thanks again, and thanks everyone online and physically for your questions and your participation. And we will have a last conference of this cycle with the Academy of Sciences, which will be, I can't remember the exact title, but on Mars and the Moon, I think. Thanks everyone.
Oui,